Hey there, welcome to Calculus 2, Math 110 this fall semester at Humboldt State University. I'm Dr. Tyler Evans. I'm going to be the professor of the course. Purpose of this video is to go over the highlights of the course syllabus. What you're looking at right now is the course homepage. It's what you'll see when you log into Canvas. Over here, there's a bunch of navigation tabs, and in particular, you can navigate to the course syllabus. So I just want to hit the highlights. I strongly recommend that you read the syllabus carefully and ask me if you have any questions or you're unclear about any of our course policies. I tried to write it up as clearly as possible, but there's a lot of information here, so feel free to ask me about it. Top section, course and instructor, is basically the registration information and my contact information. This calculus page, this Canvas page, is serving two distinct sections of calculus. You might be enrolled in the 10 o'clock section, you might be enrolled in the 1 o'clock section. This page serves them both. I won't navigate to it here, I do it in the other video, but when you click on the Zoom meeting instructions, it's clearly labeled there which link you click to join the 10 o'clock lecture or the 1 o'clock lecture. If you're ever unable to make a lecture, you're certainly welcome to come to the other one. If you're in the 10 o'clock section and you can't make it someday, but you're available at 1 o'clock on the same day, feel free to click the link. I won't refuse you entry. I do strongly encourage you to attend all of these meetings, just as if we were meeting in face-to-face. It's the best way to learn mathematics. But I will, as you saw in the other video, if you haven't watched it yet, you will see in the other video, I will make kind of backup video lectures for each section, but it's certainly preferable to attend in class where you can interact with me, interact with your classmates, and get kind of a deeper overview of what we're doing. You can also join my office hours. I'll change these if it becomes necessary. It's not a good time, but you can click on that Zoom link to get the access code to that. The office hours, I'm going to start off doing it just every day at noon. Okay, prereq is HSU Math 109. It's basically Calc 1. This is a second semester of calculus. I'm kind of moving on now into the course description. Second semester of calculus continues our study of rates of change, differential and integral calculus. First third of the course, roughly speaking, will focus on techniques of integration, being able to find antiderivatives for more and more complicated functions, sort of building on that U substitution technique that you learned in Calc 1. Then we'll look at some applications of the definite integral, primarily to physics, biology, some social sciences, I hope. I'll try to kind of hit various interests. There's a lot of different majors in this course. Then we're going to turn to a different description of the XY plane, so-called polar coordinate and parametric descriptions of the XY plane, kind of hash out how the differential and integral calculus works in those settings. And then the course will end with a treatment of something called sequences and series leading up to something called Taylor polynomials, which is a way to approximate an arbitrary differentiable function with a polynomial. All right, with respect to the text, it's basically going to be chapters 6 through 11. We won't cover all of chapters 8 and all of chapter 9, but essentially we will cover almost all of chapter 6, 7, 10, and 11. All right, you can check out the other video or click on this textbook page when you're looking at the syllabus that's required text. You need to have it, and in particular, you need to have it right at the beginning of the course. What kind of devices? Well, we're going to trade things electronically, and you're going to be attending this thing virtually, right? So you need a computer. Your computer has to have an internet connection. You're going to need to have Zoom to join the class meetings or my office hours. If you want to watch some of the videos as backup or you miss a class, you'll need to be able to watch YouTube videos. So long story short, you got to have a computer with an internet connection that you can use Zoom, YouTube, a web browser, all right? And then in terms of turning in exams, you're going to have to be able to scan work and submit it as a multiple page single file PDF. I've got some suggestions on how to do that with a phone. I don't assume that you have a scanner, but I do assume that you're going to be able to digitize your work and submit it under that format. If you have any trouble with that, don't worry about it. Let me know. I'll help you work on it, but it is going to be required. So you're not going to be able to wiggle out of being able to submit those PDFs to me, but I'll help you do it if you need some help. All right, if possible, it's not required, but I strongly recommend if you can get your hands on some kind of tablet, an iPad, an Android-based tablet, something where you can basically write like you would on a piece of paper, but then it's digitized. If that's a possibility for you, I strongly suggest you try to do it. There's a page HSU has about resources to help you acquire things. Maybe the university could help you. I don't think they'll help you get a tablet, But microphones, web cameras, and so on, they're doing everything they can to facilitate this hopefully temporary switch to virtual instruction. Calculators and software. Well, we're going to be online so much that there's just online tools to do that. I put on the technical tools page something I'll use a lot called Desmos. I'll try to turn you on to some other technical tools that you can use. Probably try to use a spreadsheet here and there. But I'm not in some sense, but you need some tool where you can, given some function, given by a formula or an equation, you need to be able to generate some graph of that function. A lot of the problems that we work on in this class will require us to understand the analytic geometry of the problem, and a graphing technique, a device like Desmos or a graphing calculator or other software, it's crucial in order to deepen our understanding, okay? So you don't have to use Desmos, but it's what I'll use in most of my videos in class, and hopefully by the end of the semester, I'll have you hooked on it. Okay, let's talk about exam and quiz practice problems. So each section, check out the video where I delve into the Canvas course to see the details of this, but every day we'll cover a section or part of a section, and I'm going to assign homework problems out of the text from that. I'm not going to collect them. You're not going to write those homework problems up and turn them into me, but it is crucial that you do them. It's the way that you're going to prepare for your exams. A little bit later when we talk about the course components here and the graded components, you'll see that your exam scores are basically how I'm going to evaluate you in this course. So how do you get ready for exams? How do you become proficient and comfortable and confident for exams? You do these problems out of the book. All right. Don't feel disappointed that I'm not going to read them. I'm happy to speak to you about any one of them that you do. You can bring them to me and check them, or you can check the answers yourself on Slader. I've got a link here to a website called Slader. It goes directly to our book, and there's a detailed solution worked out to every problem in this book. I hope you'll resist the temptation to go to Slader and read other people's solutions, because reading other people's solutions to mathematics problems is fun. It's a good way to spend your time, but it will not prepare you to solve problems yourself on the exam. So you need to take the mindset in this university mathematics course that you want to learn this material. You want to learn this material if for no other reason so that you can do well on the exams and pass the course. How do you learn the material and prepare to do well on the exams? You do the practice problems in the book that I suggest, and you talk to me about ones you need help on. Okay? So you're asking, what are the graded course components then? Well, there's going to be quizzes. There's a quiz for every day of the course. They're going to be on Canvas. So you're going to submit your answers to these quizzes on Canvas. Sometimes they're open answered, sometimes drop-down menus, sometimes multiple choice. I'll try to keep it lively for a variety. The quizzes will be assigned every day. I'm not going to have them due every day. Every quiz would be due on Sunday at midnight of the week it was assigned. Okay, so you're going to think like, okay, there's 4 quizzes a week. They're all due at the same time, Sunday at midnight. I strongly recommend you do them as we go. You don't have to, but I strongly recommend you do it. Please notice that the quizzes, once you open them, they are timed. The time may vary, but it's typically going to be 30 minutes. So I'll let you I'm trying to be flexible. I'm sort of letting you choose when you sit down to do the quiz, but once you sit down to do it, you have 30 minutes. All right, there's also going to be one opportunity to submit an answer. So 30 minutes, I'm going to try to make plenty of time to do it, but you want to work carefully, double check your work and submit it once, because you're going to get one chance to do that. All right, so I'll drop 5 quizzes from your grade calculation. Every week is going to have an assignment that I'm calling reflections. What's a reflection? It's basically, I'm trying to get you to sit down and write about, in your own words, what it is we did that week. I'll try to vary the prompt a little bit, but generically speaking, there are going to be things like, well, what did we do this week in calculus? What ideas were new to you? What ideas weren't new to you? Of the ideas we talked about, how do they relate to other parts of your studies? You know, maybe you're a chemistry major. Could you tell me, yeah, I've seen something like that come up in a chemistry class. It's just a chance for you to sit down and kind of say, here's what I think we did. Maybe sometimes it'll be a chance to say, here's something about the course that works really well for me. Here's something about the course that doesn't work well. Like quizzes, reflections are always going to be due on Sundays at midnight. Okay, so sometime after Friday, when the week is over, you sit down and look at that reflection assignment. Then we're going to have exams, lots of them. I like to have lots of short focused exams. So we'll have 4 midterms and a final, 5 exams in this course. Okay, the dates are written here. You need to mark the dates in your calendar. If one of those dates, some conflict, university obligations, something else, maybe you've been planning a wedding or your parents' anniversary or something, and it lands on exactly one of those days, I can try to be flexible. I'm not going to be super flexible, but I can try to be. But you need to let me know that now. So if I haven't heard from you by the end of week 1, August 28th, about a conflict with these exams, I'm going to assume that you don't have a conflict. All right. The exams, I'm not writing them to be 12-hour long exams, but again, in the interest of a little flexibility, on each exam day, it'll be available as a PDF download on Canvas at 8 a.m. that day. You need to submit it by 11:59 that day. So I'm not claiming it's going to take all day long to do the exam. It should probably take you an hour, maybe an hour and a half if you want to work super carefully and check all your answers. But I'm letting you choose which hour, okay? I'm letting you choose which hour. On those exam days, I will not have a class meeting in which I cover new material, although I will be available online. I won't answer, of course, exam questions, but I will be available online for consultation. Okay, please note well that exams are going to be scored with little to no partial credit. You should just think of it as no partial credit. So I don't put questions on exams that are exceedingly difficult or tricky. I like to put questions on it that test the basic skills that we're learning in the course. But I don't like to score the exams by giving you some percentage of what I think you did in the problem. So as you're working on those crucially important practice problems from the textbook, one of the things that you need to be practicing is accuracy, because that's kind of part of mathematics and science and engineering is, can you carefully, accurately produce quantified answers to questions? Okay, so the exams are not going to be scored with very much partial credit. Occasionally, I mean, when I say little to no partial credit, if you essentially do a problem completely correctly, but make some tiny little error, an arithmetic error, something like that, not a conceptual error of any kind, but some sort of just tiny error, then I would give some partial credit. But for the most part, I'm going to be grading the exam questions right or wrong. Okay, final exam, it depends on which section you're in. If you're in the 10 o'clock section, then your exam is on December 16th. If you're in the 1 o'clock section, your exam is on December 14th. Same rules, opens up at 8 o'clock that day, closes at midnight. How will I calculate your grade? Here's the distribution. You can see that the midterm exams are worth 15% each. The final is weighted more. It'll be cumulative. The reflections will count for 5% of your grade. The quizzes will count for 10. Okay. Partially because of the no partial credit scheme, I use a slightly wider grade distribution than what you might be normally used to. And in particular, the minimum passing grade for the course, C-, is 55%. All right, so you need to get at least 55% course total to pass the course. Okay, this video is getting a little bit long. It's creeping up on 20 minutes. I don't want it to be too long. The rest of the syllabus has important information. I'll leave it to you to check it out. Double check these dates with the university if they're important to you, but they are last day to add, drop, change credit, no credit, and so on. Here's a detailed list of our course learning outcomes. So as we're moving through the course, you can check these things off to make sure that you have mastered them. The mathematics department also has program learning outcomes. They're listed here. The university has learning outcomes, and then a bunch of resources, links to some useful information. Maybe you'd have some accommodations in the course, add drop policies, the very important academic honesty policy. In fact, I want to say something about this. You need to familiarize yourself with the university's academic honesty policy. In particular, you're going to be submitting exams to me that you take in a non-proctored setting. I do have mechanisms to check whether or not I think that work is your own. I'm going to reserve the right, this will be part of the exam directions, but I'm going to reserve the right to ask you to meet me on Zoom and clarify anything that I can't understand on your work. And in the event that I believe you have violated the university's academic honesty policy, then I'm going to refer any student in that camp to the dean of students and invoke the university's academic policy, which usually results in a failing grade in the course. All right, so if you cheat, for lack of a better word, on an assignment or exam, you're certainly going to receive a 0 on that assignment and an exam, and you're probably going to receive a failing grade in the course, depending on the outcome of the student team. So I hope that all of this is vestigial. Let's just not go there. Turn in your own work to the best of your ability throughout the entire course, and we don't have to worry about the university's academic honesty policy, but please do familiarize yourself with it. Okay, so I'll leave the rest of these things to you, and then I kind of went over some of this. I hope you're going to read it. It'd be nice. I tried to write it as carefully as I could, but I wrote some advice about what I think it takes to be successful in a university mathematics course. So I'll let you check that out. I mean, just to briefly summarize it, what does it take to be successful? An interest. You have to be interested in learning the material, kind of put in some time and energy into doing that. And if you do that, then you're going to win. Okay, I'm going to try the best I can in this virtual setting to share my enthusiasm for mathematics. I love mathematics. I love teaching calculus. So I hope that can come through in the course. Okay, so I'm going to keep this video around that. That's about the 20-minute mark. Thank you for listening, and I look forward to meeting with you in class.